Welcome back to Namaste Node.js, and in this video we are going to talk about databases and we will create our first database in this episode. Okay, so let's just begin. First of all, let me start with telling you a small story. So what happened was, once I was giving an interview. In that interview, the interviewer asked me that, Akshay, what is a database? And you know what did I say? I said, okay, database is a place where I store data, right? And let me also ask you this question, okay? If somebody asks you that what is a database, what will you answer? Okay, what answer will you get? So generally, I told the interviewer that okay, database is like a place where you store data, and that was such a dumb answer. And I was thinking for few minutes, right? After the interview, I was thinking and I was feeling that, okay, how dumb of an answer it was, right? I mean, a place where you store data is a database, right? Actually, it is what it is, right? I mean, it is actually a place where you store data, but then this answer is not very good for interviews, right? I mean, I don't know what the interviewer was expecting. And I don't know, I found it very weird, right? That moment was very weird because I had no other answer for it, right? I just said, okay, it's a place where you store database. It's a place where you store data. And then I talked about MySQL and all that stuff, right? SQL, relational database and all that stuff. Though I cleared the interview, right? It was not big of a problem. But then later on when I was right after the interview, when I was thinking about it, I said that, okay, what a dumb answer did I give? But anyways, right, whatever happened in the interview happened. But right now, let me tell you what is a database, because knowing how to tell what is a database is also a thing, right? You should know how, if somebody asks you, right, what is a database, you should be able to tell them, right, what's a database actually is. So that's how. Let us just see the actual definition of a database. In computing, a database is an organized collection of data. Okay, so the word organized is very important over here. If you just keep any data anywhere in any format, it does not mean it's a database, right? It's not a database. Database means you are organizing the data in a way so that you can perform certain operations easily, right? You can basically add data in that structured format, in an organized format, right? You can say it's a structured or an organized collection. Okay, you can also use the word structured, or you can use the word organized, because these two words are very important when it comes when you're talking about the data or database, right? So structured or organized way to, right, basically it's an organized collection of data or a structured way of collecting data, right? It's known as a database, right? The word organized or structured is very important. Now, one more thing is, there is a confusion, right? What is a database? And you might have heard of a term, database management system, DBMS, right? So, often this word database is loosely used, right? When I say loosely used, basically, we don't actually know. See, let me try to explain you. There is a place where we stored data in a structured way, right? That is known as a database. But on top of it, there is a layer of database management system. Now, database management system is kind of like, right, basically it is a way that I can interact with that data. Suppose if I want to add more data, if I want to get some data out of it, right? So you need a layer, right? There is a layer of database management system. That's a way users can, right, basically talk to that database, right? Because database is just a data store, right? You are just storing some data in a organized way. But to fetch data efficiently, to put data efficiently into the database, right, you need a management system. That management system is known as database management system, DBMS. So sometimes when I say database, so sometimes we are referring to database management system. Sometimes we are referring to the actual database. And sometimes we are referring to the application which is connecting to the database, right? So that is what it says. Go through this definition. It will make more sense to you. But what I am trying to say is, if somebody asks you in an interview what is a database, you should have a better answer than, right, it's a place where you store data. Okay. You can have a better answer. So basically, see, let me just quickly go through this also. See, database management system, the software that interacts with end users application and the data feeds itself to capture, analyze the data, right? Read this line. What is database management system? Database management system is a software that interacts with end users applications and the database itself to capture, analyze the data. Okay, got it? So basically, database management system is a software. Suppose this is a software. Here is the database, right? This is the database. Let's call this as database. This is DBMS. And now suppose if your application is requesting some data, right? Suppose this is a software. Let's call this as an application. This is an application. Now DBMS is a software. This piece is a software which interacts with user application and database itself. Now it interacts with the application also, it interacts with the DB also. It's basically sitting in between. It can talk to the database, it can talk to the end users or the applications also, and then it manages everything, right? So that's why it is known as database management system, DBMS. Okay, so now read this line also. This is very, very good line. Often the term database is loosely used to refer any of the database management system or application associated with the database. Okay, so database is loosely used. It depends on what context are you using this word database. Just like servers, in one of the episode, in the previous episode, we saw that, okay, the word server is also loosely used. Sometimes it is referred to a software, sometimes it is referred to a hardware. So similar to that, database is also is used loosely, right? So that's how it is. Now let us just move ahead and talk about what are the different types of database we have, right? So there are multiple types of database, right? So I have listed down a few, but there are much more types of database. And let me tell you that some databases are of multiple types and these types are related to each other also. Okay, so let me tell you that, okay, in NoSQL database, there is a GraphDB type, right? Inside NoSQL database, there is a type of GraphDB, right? So GraphDB is type of a NoSQL database. So these are interlinked. Don't worry much about it. You don't have to learn about these types of database. I'm just telling you, I'm just giving you this information so that you are aware of it. Let me tell you, in my journey, right, it has been more than 10 years in the industry, software industry. I have just used two databases in my life, right? Two types of databases. Not two types of databases, 3-4 types of databases. But so what I'm trying to say is having the knowledge of all the database, every type of database is not required. It depends on use cases. Every database serves a different purpose. So your application might not be needing a lot of type of databases. So don't worry about it. You don't have to learn anything from this system, from this slide. The only thing you should know is there are so many types of database, right? This you should know, right? So let me tell you what are different types of database. There is a relational database. There is a NoSQL database, just like MongoDB you might have heard of. You might have also worked upon MySQL or PostgreSQL, right? PostgreSQL, this is also known as Postgres, okay? Postgres, it's commonly known as Postgres. So Postgres, MySQL, right? So these are the two relational databases. There is an in-memory database, Redis. So I have worked with MySQL, I have used Postgres, I have used Mongo, I have used Redis, right? And I have also used Amazon RDS, right? And the other databases I have not actually used any time, right? I have not actually used it in production, right? Somewhere in a live application. I have just tested out some of the others, right? Here and there in my personal projects or something, just to explore them. But I have not in my companies, right? Throughout my career, I have been into like 4 or 5 companies, right? And in 4 or 5 companies, I never got a chance to interact with other types of databases. Okay. So I also have a limited knowledge of databases, but whatever knowledge I have, I will give it to you, right? What I have personally used and what majority of the companies use is relational databases, NoSQL, right? These are the two most widely used types of databases. And most of the times when somebody is talking about databases, they are generally talking about these two types, right? There are multiple types of database, but generally they are talking about this, right? The core database companies have is one of them. Now also let me tell you, right? There is a very dumb question. I should not say a dumb question. Basically, no question is dumb actually. But a student asked me a question that, okay, what is, suppose, let me tell you what the student asked me. I don't even remember what student asked me, but somebody asked me this question, that Akshay, in Google, what database is used? In Uber, what database is used? In Amazon, what database is used? So never think that one company is just using one database. It's foolish to think like that, right? So what I'm trying to say is that if the company is big, they have different type of challenges, different type of projects, and each project can have a different database, right? Different type of database. If you talk about Google, Google might be using almost all of them, right? For their different products. Somewhere they might be using MySQL, somewhere they might be using MongoDB, somewhere they might be using different type of databases, right? So one company is not restricted to one type of database. They can have multiple type of database. A database is very much project specific, not a company specific thing, right? But let me give you an example. We at Namaste Dev, right? The website where you are watching these videos probably, namastedev.com. This website uses MongoDB, right? We are using a NoSQL database, MongoDB, behind the scenes. And that is what I am going to teach you in this course. Okay, that is what I am going to teach you in this course. So this is what I will teach you. But I am just telling you that there are different type of databases, right? So relational database, MySQL, Postgres, NoSQL, MongoDB is very famous, most famous. MySQL is very famous. Postgres is very famous. Now Redis is also very famous. Redis is basically used for caching, in-memory caching, right? Basically, I'm not going deeper into it, but then what happens is, suppose if there are some APIs which are frequently used, right? Suppose if you are fetching some data frequently. So we keep some data in Redis. So basically what does it means? Redis is a basically kind of like a cache. So it's a cache, it's very fast. It's kind of like, so you might have heard of the concept of RAM and ROM, right? So basically RAM is a faster memory, right? But it cannot store a large amount of data. It can store a small amount of data. And then there is an actual memory and a storage on the computer, right? ROM. So similarly, RAM, ROM, similarly you can have Redis, and then you can have your actual database. So if somebody is making an API call, so it first will check the cache, it will check the Redis. If it is available, it will quickly give it. Otherwise, it will go hit the database, right? So if you use Redis, then your APIs become faster sometimes, right? And not always, but then sometimes it becomes faster. So Redis is very popular. Many companies use Redis. We are not using Redis as of now, but we are planning to use Redis, right? So distributed SQL, right? There is a DB known as CockroachDB, right? Read more about it. I have never used it. I don't know much about CockroachDB, but the name sounds cool, right? I thought once that, okay, I will go and explore CockroachDB, but I could not do that, right? So anyways, there's a time series database, InfluxDB. There is object-oriented database. There are graph database, Neo4j, right? This is also a type of a NoSQL database, right? So there is a hierarchical DB, IBM, IMS, right? This is, I think, information management system. IBM information management system. There is a network DB. There is a cloud DB, Amazon RDS. So basically, it's basically a part of Amazon's implementation of relational database available on cloud, right? So don't have to know more about it. There are multiple different type of databases also. Something like there's a multi-model database where I'll talk a little bit more about it, but there is a multi-model database also, right? So you don't have to know everything about it. Just keep in your mind few databases. See, each and every database. Now you might ask me, Akshay, what is difference between all of them? Then if you don't have to know much about it, what is the use of having so many types of database, right? This is a very famous question. Now see, every database has its own core purpose. You can store data in multiple ways. Multiple ways. Let me tell you an example of data structures, right? So there are multiple types of data structures, isn't it? There is arrays, there is linked list, there is trees, there is graphs, isn't it? And even inside trees, there are different types of trees. There is a red black tree, there is a binary tree, there is a binary search tree, there is a heap, right? So many types of database trees are there, right? So if you consider, there are so many types of data structures. Each and every data structure has a pros and cons of it, right? And there are use cases for using each type of data structure. Similarly, over here in databases also, there are different type of databases. Each of them have its own pros and cons. Some databases are very good at storing transactions, right? So I'm not going into much detail, otherwise this would become Namaste database, right? It will take a whole new series to cover the types of database and going into the depth of database. But assume that, okay, some database are read heavy database, some database are write heavy database, some database are different types of databases are there, right? It depends on the use case. What do you want to do with that data? Got it? So it all depends on that. So this is a brief summary of the types of databases. Now we will, in this episode going forward, I will talk more about these two types of database, because these are the most common widely used databases. And probably if you will make an app, if you'll go in a company, do a job, or if you're already in a job working on something, you might be using one of these, isn't it? You might be using a SQL or a Mongo NoSQL database, right? So these are widely used. MongoDB is widely used with Node.js, and that is why it is known as MERN stack, right? Mongo, Express, React and Node, MERN stack, that is what we call it as. So this is one, MongoDB. We will be focusing more on that. Now let's go ahead. Let me talk a little bit more about the relational database, okay? So, let me tell you a little bit about relational database. So relational databases, basically, in 90s, 70s, and 1980s, right? The wave of relational databases started, right? Basically, relational databases were introduced in 90s, 70s, and 80s, right? In 70s and 80s, right? And there was a famous mathematician scientist, right? His name was E.F. Cord, right? E.F. Cord. Okay, so I think the name is Edgar F. Cord or something. I don't know much about it. So this scientist mathematician, he was a great scientist, and I think he won a lot of awards also. Not sure what awards he got, but he was a very famous person, right? And he introduced a concept of Cord's 12 rules. Right? So he gave 12 rules. No, actually, let me tell you, these rules were not 12, right? It is known as 12 rules, but the rules were 13. But why it is known as 12 rules is, there is an interesting story behind it. So he numbered his rules from 0 to 12. Okay. So he numbered these rules from 0 to 12. Now, because he was into computers, right? And the zero indexing was in his head. So he named the rules from 0 to 12, right? So because the 12 was the last number, so people started calling it 12, Cord's 12 rules, right? But it's not actually 12, but it's 13 rules. But the phrase is Cord's 12 rules, so that is what I'm telling you, right? It's not my thing. Okay, so you can go read about it. So he defined 12 rules. Now, what are these 12 rules? I'm not going to cover all these 12 rules because it's of no use for you. But basically, he designed these rules to tell that if your database follows these 12 rules, it becomes a relational database. Okay. So these 12 rules were applicable to RDB, relational database. Relational database. Okay. So if you want to create a relational database, so he introduced relational databases, and he said that, okay, you'll get to know the word of relational. So RDBMS means Relational Database Management System. So relational database means you have different tables and you have relations between these tables. So data model, right, is relational. Okay. So I will talk a little bit more about it very soon. Don't worry about it. But then assume that, okay, these are 12 rules, which says that, okay, if these follows 12 rules, then it becomes a relational database. Now, but these rules were very tough to follow. There is still a debate that modern databases do not follow these 12 rules, but still are known as relational databases. But that's another story. We don't have to go inside that, right? But then that's how it is. But these are 12 rules which kind of defines that, okay, this is a relational database. Got it? Now, now in 1980s, relational database became kind of like started becoming a major place to store data, and it gained a lot of popularity old back, right? In 80s, this happened. I was not even there, right? But what happened is, then let me tell you, there were two databases in RDBMS also. There are so many databases which are RDBMS, but the two most famous databases are MySQL and PostgreSQL, and both of them has a interesting story. Okay, so let me tell you the story of MySQL. Okay, so let me tell you the story of MySQL. So MySQL was developed by a scientist which was known as Michael, what was the name? Widenius, I think. Widenius. I'm not sure that I'm spelling it correctly, but it was Michael Widenius. Okay, this was a computer engineer who created MySQL, and there's a very interesting story behind the name MySQL. Now, a lot of people would say that, okay, it's a SQL database and MySQL means MySQL. Okay, no, but the name did not come like this. Let me tell you the interesting story behind it. So this guy, Michael Widenius, had 3 daughters. Okay, now 3 daughters. The first daughter's name was Mai, the second daughter's name was Max, and the third daughter's name was Maria. Okay, so Mai was the eldest daughter, right? So he named this SQL database after her name. Okay, so that is why it is known as MySQL. It's an interesting story. So okay, so that is why I wanted to tell you that, okay, MySQL came from his name. Later on, he was into relational databases, right? Michael Widenius was into relational databases. He created one more relational database. It was majorly for enterprises. I don't know much about it, but he named it as MaxDB, right? And this MaxDB came after the name of his second daughter. And he also created MariaDB, right? MariaDB, which was named after his third daughter. Now, MariaDB basically is a fork of MySQL, right? So it is basically a clone of MySQL. Now, why did he created the clone of MySQL? That is also an interesting story. If you go story behind story, if you dig deeper, then you will find a lot of interesting stories behind the history of computer science. But let me tell you what was the story. So MySQL, I don't know the year, but MySQL was acquired by the company which was known as Sun Microsystem, if you know about it. Sun Microsystem has played a lot of important role in the evolution of computer science, trust me, right? This company, you will hear about Sun, right? Sun Microsystem a lot, right? It's a very famous big company, right? Sun Microsystems, right? They acquired MySQL. Got it? They acquired MySQL. And then later on, I think an year later, what happened? Sun Microsystem is now acquired by Oracle, right? So basically, if you will see at the current, MySQL database is being managed by Oracle, right? Oracle company, Oracle, right? I don't know. Some people say Oracle and some people say Oracle. I don't know, right? What is the correct pronunciation for it? But let's call it as Oracle, right? So this Oracle company is now managing MySQL. So what happened when the acquisition happened, right? So Michael Widnius and the other core team of MySQL, they created a fork, and that fork was known as MariaDB, right? And there is a GNU license. I'm not going into much detail, but then it's a fork of MySQL and it is derived from MySQL, right? That is kind of like a brief history of MySQL, and if you go deeper, then there is a lot more story behind all of it. But right now, at present, MySQL is managed by Oracle company. Got it? So this was about MySQL. It was named after his daughter, My. And then there was a MaxDB and a MariaDB and all that stuff. You don't need to know about anything, right? Nobody will ask this in interviews or something. I know this because of curiosity. I was very curious, so I was reading about it. But there is nothing to learn or know about this, right? If you want to skip it, skip it. But I personally am very curious and I love to read about all this stuff. Because when you know the history, when you know how it evolved, you get more attached to things, right? I don't know. I want to, if I'm working on something, I want to know how it was created, when it was created, who created it, who was that brilliant mind who created all these things, what happens inside these things, what happens inside MySQL, how MySQL is written, all these things, it comes out of curiosity. So I also urge all my students to be curious, right? Just like I am curious, and curiosity has taken me to great places, right? Curiosity, being curious, has helped me a lot in my life, and that is what I would request you to be. Be curious, ask a lot of questions to internet. Now you have the access to internet, to chat GPT and all that stuff, right? All the AI. Ask a lot of questions, ask good questions, get answers, and that is what will increase your knowledge. Okay. So my humble request. Let's move ahead. Let me go to another story about Postgres, right? Postgres. So Postgres, there was again a scientist. Coincidentally, his name was also Michael, 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 and Stonebreaker. Okay. Stonebreaker, Breaker. Okay. So his name was Michael Stonebreaker. So this guy was working on a project Ingress. Where? Right? This guy was working on a project Ingress. Now this project was this project was a part of University of California, right? It's a very famous university in Berkeley, right? In Berkeley, University of California. He started building the project Ingress, right? Project Ingress. Now, he started building it, worked from it. Then later on, he built the kind of like, he left the university and then he again came back to the universities 1985 or something. He left and started working on something else. And then he came back again in the university and started a new project, which was known as Post Ingress. Right? So Post Ingress was the name of it. Post Ingress. Basically, it came from Ingress. So that is why he named it as Post Ingress. And then later on, this name evolved to be, so see, Post Ingress, and the project was of SQL, right? I will tell you what is SQL over here. SQL means structured query language. I will tell you what it is. But all the relational databases, RDBMS uses SQL. I will tell you what is SQL right now. But think about it. So he was creating a relational database and it was Post Ingress and SQL. So the name became Postgres and then SQL, right? Something like this, right? But this is the official name of it, but people call it Postgres. Okay, so if you want to refer it, you can call it Postgres. This is the widely used word for it. But this is the story behind it, right? And Postgres is also very famous, right? A lot of companies who want to work upon relational RDBMS, they use Postgres, right? On production, right? It's a very, very, very famous database. And just go to their official website, check out Postgres, right? It's a very famous database, right? Now, I was talking about SQL. What is SQL? SQL means structured query language. Okay, let me write it down somewhere. Structured query language. language. Okay. Now I told you, right? So database is a, what is database? Organized collection of data, right? You have a place where data is stored in an organized and a structured fashion. That is known as database, right? Now you need a way to interact with that database. Also, you need to put some data into it, get some data out of it. You need a database management system. So when you are putting data into it, when you are getting data into it, these things are known as queries. So you'd make a query, get query, post query. You might have heard of get query and all that stuff, right? So you need a query language to interact with that database. That is a structured query language, right? That structured query language is used in RDBMS. That is why it is known as SQL databases also, right? Whenever you will heard the word SQL or SQL, right? It is known as structured query language. So pronouncing SQL is tough every time, so people call it SQL. So SQL database, okay? So you will heard the word SQL database. So it's not a sequel of something. It's SQL's pronunciation that evolved to be SQL, okay? So SQL database, right? MySQL. People call it as MySQL. People call it as MySQL, right? So that's how it is. Funny, but that's how things are. Hope you would have understood the whole history about it and all that stuff, right? That's how relational databases evolved. I'll talk a little bit more about it going further, but for now, I think this is enough information. Interesting information, right? I wanted to share with you. Now let's move to NoSQL databases, right? In NoSQL database, there are multiple types of NoSQL databases also, okay? So should I tell you about the types, okay? Let me tell you about the types also, okay? Why not? When we are talking, there are majorly 4 types of MySQL database, right? The first is document DB, right? Document database, right? The other type is key value, right? And the other type is key value DB. The other type is graph DB, right? Graph DB. And there is one more type which is known as wide column DB. Okay. Now, if you are curious, go read about all of it. And there is one more type actually that is known as multi-model. Okay. So if I'm explaining you, then let me talk about all of it. So multi-model means, right? This multi-model means that, okay, it comprises of multiple models, right? There are different models of databases. It consists of it's kind of like a mix of multiple types of NoSQL databases. Got it? So, but let me tell you, out of these, MongoDB is a document database, right? MongoDB uses documents, right? And this is what we are going to study out of it. But for your knowledge, I told you what are 4 types of NoSQL database. Now, what do you mean by NoSQL? There is another interesting story about it. Some people call it as non-SQL. NoSQL means it's not SQL, right? NoSQL means non-SQL, not SQL, whatever. But let me tell you, the people who work with NoSQL databases often call this as not only SQL, right? There is a difference. Not only SQL. Basically, they try to portray this database as it's not just SQL, it's much more, right? So that's why they call it as not only SQL, right? It's an abbreviation. So basically, there is no formal abbreviation for NoSQL databases. Some people call this as non-SQL database, not SQL database, right? Get a better name or something, right? The RDBMS community is like, it's a not SQL kind of a database. It's not very good or something, right? There's a very big debate also, right? This database is good, this database is good and all that stuff. But then don't go into all of it. But the NoSQL community calls it as not only SQL, right? If we'll go to MongoDB website and a lot of other NoSQL databases, they always call themselves as not only SQL, right? We are just not only SQL, we are much more than that. And we will talk more about what are the what are the big traits of NoSQL databases and why NoSQL database is important and why it is so popular also, right? We will talk about a lot about NoSQL database in this whole series. So don't worry about it. We will work on it. We will actually create a NoSQL database, a MongoDB right in front of you. I will tell you, don't worry, in this episode itself. Don't worry. I'm just giving you this information. It's called as, like, it's known as not only SQL. So this is an interesting thing. Now let me also tell you that this NoSQL thing, the wave of NoSQL started in late 2000s, right? Very recent, right? The relational databases are going on since 70s, 80s, 90s was the era of relational databases. Till today, let me tell you, don't undermine relational database. Till today, major big applications, banking applications, everywhere uses relational databases, right? It has its own pros and cons. But MongoDB, NoSQL, this came up in 2000s, right? In 2000s, this concept of NoSQL was introduced and it started becoming very popular, right? This was a new way of storing data. Earlier, before that, RDBMS was very, 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 very popular. Let me talk a little bit more about MongoDB now, right? When we are talking about so many things. So let me talk a little bit about MongoDB. Let me take this marker. So if I talk about MongoDB, right? So first of all, MongoDB was, created in year 2009, right? I think it was started in 2007 and then it took 2 years to build MongoDB. I don't know the exact numbers or how it happened, but then I remember that, okay, in 2009, MongoDB became very famous. And remember, this was the same time, and I would call it as a coincidence, that at the same time of Node.js, right? Node.js was also released at the same time, almost similar time. So while Node.js was new and getting popular, MongoDB was getting new and it was also getting popular. And I don't know, but somehow Node.js and MongoDB go hand in hand, right? It's when you are writing code in Node.js and in MongoDB, they go hand in hand and it looks like they were made for each other, right? I'm not getting for the sake of better words, for the lack of better words. I'm just saying that, okay, they go hand in hand and looks like they were made for each other. They have a very good bond, right? And MongoDB goes well with the JSON, right? And JavaScript objects. So when you are using JavaScript, MongoDB becomes very easy to write as a developer and it's very much compatible with Node.js, I would say, right? And we will see this, right, as we go through this series. So that is why I'm talking a lot more about MongoDB, because it's very fun to work with MongoDB. It's very easy, right? And it's very amazing also, right? Okay, so let me also talk a little bit more about it. So if I have to tell you how, okay, let me tell you the history of MongoDB. So basically why people named it as MongoDB. Okay, so let me first of all tell you who created MongoDB. So MongoDB was developed by a company which was known as 10gen. Okay, this company was known as 10gen, right? And they created MongoDB. And the name Mongo, how did the name Mongo came in, right? That's also an interesting story. So basically, this word Mongo came from the word humongous. Okay, so there is a word humongous. This means gigantic and huge, right? Large, very big. This is the meaning of this word humongous. And the word Mongo came from it, right? The word Mongo came from humongous. Not that exciting, crazy story, but that's how MongoDB came in. And it was supposed to hold huge amount of data. And that's how it is, right? It can support and it can store a huge amount of data, and that too unstructured data, right? That does not have a fixed schema. We will talk about all of it also. But that is what it was meant for. And it can scale. It can scale vertical, it can scale horizontal. And that's how MongoDB is capable of it. Now, later on, what happened? This company, 10gen, right, created this. And then later on, this 10gen company created MongoDB. They were working on a lot more things. But then they later focused their 100% attention on MongoDB, right? they started working fully on MongoDB, and they even changed the name of their company, right? They created the company with the same name of their database, right? And then this company then later on changed to be MongoDB, INC, right? And this is the company which manages MongoDB. Okay, so that's how the story of MongoDB is. So earlier this company Tengen. So if you will read some older articles, so you will read about Tengen. Okay, later on it became MongoDB INC. This is the same company which manages the MongoDB database. So now there are a lot more amazing things about MongoDB, and we will talk about it, right? So MongoDB is very flexible. It's very much developer friendly, I would say, right? Various reasons why people use MongoDB, why it is popular. It is very flexible. It does not have a very rigid kind of a contract or something. It is very compatible with Node.js, very compatible with JS stack, right? So if you'll work with Node.js or something, so it's very much compatible. It stores data in JSON, in documents, right? And documents map to JSON very well, right? We will see all of it. Don't you worry if you don't know about it. And it increases the developer productivity, that dev productivity, right? If you'll see, it increases the developer productivity, goes up, right? It's very easy to write code and manage all of it. So that is why it is very popular. And a lot of people ask me, okay, if you are interested, go see about how MongoDB was built, read more about it. But let me give you one more thing, that, right, this MongoDB is built using C++, right? It has some JavaScript code, it has some C++ code, it has some Python code. So all these databases also actually are built using some language. Okay, so don't think that database is some fancy thing. Some people don't actually understand. They think that database is something very different, very unique. I don't know what is happening. It's something amazing, something happening. No, at the end of the day, everything is kind of like code, right? You are storing some data in piece of binaries and all that stuff, right? So don't you worry. At the end of the day, you need languages to create everything. So it is also built using some lower level languages like C++, JavaScript, Python, all of it is used, right? So, okay, so it's interesting when I tell these things to my students, they are sometimes amused, right? They feel that, okay, there must be some other way of some other technology for creating database or something. No, nothing like that. Database is just a, way to communicate that, okay, this portion of code is doing something which is very much relevant to databases, right? So, and managing the data, getting the data out from the database, pushing the data in, right? It's at the end of the day, it's code. It's all code, right? That we write. There are some people who have written that lower level language code, right? Which interacts with the computer and very low language code. But at the end of the day, it's code, right? The computer and everything runs on machines, right? What is operating system? It's kind of like some code running behind the scenes, isn't it? Some program running. So it's amazing, right? How we are dependent so much on these computers and everything. The world is working on web, internet, and we have come a long way, right? We have come a long way, isn't it? Amazing. Whenever I read more about the history, whenever I read more about the stories of how things were built, there have been great mathematicians, great scientists who have come up, who think about someone, right, in 1970s, writing 12 rules to creating a relational database that, okay, data can be modeled into these tables and then they can have a relation. There can be a primary key, there can be a foreign key, and all these things, thinking about that. And then so many years later, even today, we are using those concepts and using all these database knowledge. How cool is it, isn't it? Right? We have come a long way, right? And it's not that long also, right? 80s means like 30, 40 years back. 40 years back, 40, 50 years back, right? So computer science in itself is very new for us, right? It's just 40, 50 years, not more than that, right? One generation above, right? Like my father knows about computers and he was able to work on computers, but then their fathers did not know about computers, isn't it? It's very recent thing, but we have come so far and it has become a part of our life so much that we are so much dependent on it, isn't it? Right? Think about it. How fast we are moving in this technological era. Now we are talking about AI, machine learning, and this and that, and GPTs and supercomputers and whatnot, right? Amazing. Bitcoins and blockchains and whatnot. So the tech is evolving very fast, and I feel that it's such a great thing that I am a software engineer. I don't know if I was not a software engineer, what else I could have done. I can't even think about it, right? I feel that it's the best life I have got. Somehow, from the God's grace, I believe I'm a very big admirer of God, right? I believe in God. And with God's grace, I have got a chance to be a software engineer, and that too became a teacher. And it's such an amazing feeling, trust me. If I was just a software engineer, I would just be working, writing code and all. If I'm a teacher, I need to study before I tell you, right? I need to be curious myself. I need to go study, research about it. And that enjoyment that I get while I'm studying, preparing for lectures, preparing for these episodes and teaching you all is tremendous, right? This would have only be possible with you and with God's grace, right? So I'm always grateful for this profession. But again, right, I feel myself to be lucky. Fingers crossed, right? Hope everything goes well. But yes, okay, so that's how things are. So let's move ahead now without wasting much time. So let me tell you the difference between RDBMS and NoSQL, right? So this is I am right now talking about MongoDB over here, not talking about basically the other types of NoSQL, right? Basically, I'm talking about the document databases. So data in MySQL is stored in this format, okay? MySQL or relational database is stored in format of tables, okay? So in RDBMS, suppose if you have to store this photo, this picture that you see, I have taken it from an online article on MongoDB website. You can go and read that article also. If you'll search for RDBMS vs NoSQL, you will go to a MongoDB official website. You will find this diagram over there. It has a beautiful explanation on the blog, but that is why I took the image as it is over here in my explanations. It's a very beautiful image. I can explain you everything thoroughly, but I would request you to go to MongoDB website, search for RDBMS vs NoSQL on Google. You will find a MongoDB link. Go to that, read about it. You will get your information, your knowledge will be even more strengthened if you will read that. Okay, cool. So in RDBMS, see, you create tables. Every table has a column and rows, right? So this is one row. This is one row. These are columns, right? Columns. And this is a table, right? So RDBMS works in table, row and columns. Now suppose if you want to store some data, you can store it like this. Suppose if this is a user table, it stores the information about the user. What it stores? Right now seeing this table, you can say that, okay, it is storing the first name, last name, cell number, right? Basically phone number and city, right? This is what it is storing. Suppose it has to store my data, so it will create one more record over here. I should not call this as record. I will call this as a row. It will create one more row and give me another ID. Let's call it as 2. And then it will take my first name Akshay. It will take my last name Seni. And it will take my cell number. I'm not giving you my cell number, but let's say something. And then it will give me my city, Dehradun. Right? So similarly, one more row will be created. And similarly, multiple users coming in, multiple data being stored. So similarly, in form of a table, just like an Excel sheet, you can think of a table is nothing like but an Excel sheet. It has multiple columns, it has rows. You put in data, it just keeps getting one row at a time, right? That's how it is stored. Now, RDBMS, important word is R over here, which means relation. So now, suppose this was the user table. But suppose now you want to store the hobby of users also. So now there are two ways to store the hobby. Either I can create a new column over here. I can create one more column and I can store it in that column, the hobby of the user. But no, right? There are different the best thing is to keep things separate. Relational database works in a philosophy where you need to keep the different things in a separate table, right? So basically, now, if I go deeper into it, why hobbies should be kept separate, it depends on application to application. So don't worry much about it if you don't understand it right away. But think that, okay, suppose if we wanted to store hobbies of the user, so I can create a new table for hobby. Right? Now this table, suppose if I want to store some hobbies for Leslie, right? Leslie, Leslie, right? Leslie. So what I will do, I will create a new table, right? Suppose this Leslie has 3 hobbies: scrapbooking, eating waffles, and working, right? So it will be stored like this, and these tables will have a relation, and this will be mapped by one ID, right? These two tables are separate. Think about different sheets inside your Excel document, right? You have multiple sheets. Similarly, think about a separate new sheet for keeping the hobby. Now, this is mapped by user ID. So user ID of Leslie is 1. So for one user ID, scrapbooking. And this is the ID of hobby. This is the hobby ID basically, right? This is the ID of hobby. Every table has its own ID, right? Every table has its own unique identifier. There should be a unique identifier in all the tables, right? So similarly, and then to store the hobbies, it will be stored like this. First will be scrapbooking, one more waffles, one more working, right? So this is why you can't just dump data. You can't store arrays, right? Like this. You can't directly store arrays over here. You can store objects, arrays, and higher level types of data into relational database. And that's how it is. That's how these databases are designed. Okay. So that's how you can query also in top of it. Suppose if I wanted to store the hobbies for Akshay Saini, how would I store? Right? So suppose if I want to store, so basically there would be an ID over here. Let's call it this as 13. And in this table, I can have a user ID. Now this user ID is the user ID of the user, right? This ID. So either over here it will come 2, and over here it will come, suppose my hobby is JavaScript, right? JavaScript. So you can store it like this inside this table. Now if suppose if I want to store one more hobby for Leslie, so you can again create a user ID 1 and 14, and you can just get some hobby XYZ, right? So similarly, this is how the data is modeled and structured in a relational database, and these tables are related, right? So there is a concept of primary key, there is a concept of foreign key, right? And a lot more stuff. Go read about it on the internet. I'm not covering relational databases in deeper in this video, right? I'm not doing that because we want to focus more upon the NoSQL and Mongo part. This is what we are going to use, right? Throughout the course also. When we will build the projects, right? In the next season, when we will build the projects, so we will be using MongoDB. So focus upon MongoDB a lot, right? We won't be using RDBMS. Now, let's talk about NoSQL and document database or MongoDB now, right? In MongoDB. So in MongoDB, you don't have a table. You call it a collection. Okay. You call it as a collection, right? There is a collection, and then this one, and you store the data in form of a, now what comes to your mind when you see this? Some people call this as JSON. Some people call this as a JavaScript object, right? But MongoDB call this as, and this is actually called as not just MongoDB. This is called as a document. This is a document. This is one document. So basically, right, if I talk about the relational database, so you have a table. Similarly, you have a collection over here. In this table, you have different rows, right? This is one row, this is second row, this is row, this is row, this is row, this is row. Similarly, for storing one row, it is kind of like stored in this format, and this is known as a document, right? This is known as a document, one document. Got it? So it has collection and documents. And this one thing, these things are known as fields, right? This document has 1, 2, 3, 4, 5, 6 fields. Got it? Fields. So this is how you have the data inside your NoSQL document, NoSQL or MongoDB. And if you will see, there is no need of data normalization. There is no need of joins. Data normalization means that data could not be like hierarchical or stored in like arrays or something. You need to normalize data. Read about normalization of database. It's again a big concept in itself, normalization. But you don't have to think about that. You don't need data normalization. You don't need joins. So if you want to get data between, suppose if you want to get the hobbies of all these, suppose if you want to get the hobby of Akshay Saini, so you basically have to create a join two tables, get the data and send it back, right? So you use joins over here. Here you don't need joins. Here you don't need joins, and you will see how we can get the data and do a lot of stuff. Now, suppose if you want to store the hobbies of the user, you don't create a new table. You can just store this array over here. Easy, right? Easy. That's how programmers think that, okay, suppose if we have multiple hobbies, I will create an array of strings. That's it, right? So similarly, see, Leslie, yep, cell number, city, and hobbies, all of it are stored in just one document. You can just keep a one document, right, inside one collection, and your job is done. Now, you can't keep like everything into a same collection. There can be multiple collections, just like we can have multiple tables, but you don't need to actually normalize at a very deeper level, right? You don't have to like keep these hobbies in a separate collection or something. No, this is a good way of storing data. Suppose if I have to add Akshay Saini's data also over here, how would I add? I would add one more document with all these fields. I would get an ID of 2, and then I would get a first name of Akshay, I will get a last name of Saini, I will get a cell number, I will get a city, I will get hobbies, and hobbies will be an array of whatever my hobbies are. Got it? So this object kind of a format, this JSON kind of a thing, this JS object kind of a thing, right, is known as a document. Always remember the word collection and document, right? That is widely used. Now, why MongoDB is popular? The one reason is document also, because this document looks like a JavaScript object and JSON, isn't it? And JSON and JavaScript is the language for web applications, isn't it? If you'll go to browsers, you will find JavaScript, you will find JavaScript objects, JSON, the data is being transferred via API calls in JSON format, right? So that is why it becomes very easy to deal with these Mongo documents, right? Inside JavaScript. Very easy to deal with that. We will see it very shortly. Don't worry about it. Got it? So these are the information I wanted to give, right, about RDBMS vs NoSQL. But let's go and see more differences between RDBMS and NoSQL. Okay. So let's just go and talk more about it. Now, cool. So now don't get afraid by seeing all this. I have written it before, right? So that it becomes easier for me to explain you. Now in RDBMS, you have already seen that we use table, rows and columns. Over in NoSQL database, we use collection, document and fields. You understood, right? Let me just tell you once again. You have a table. This is known as full table. This is row. This is column, right? These are columns. Got it? In NoSQL, we have collection, document and fields. This one thing is fields. There are 7 fields over here. Got it? So we have document, collection and fields. So table, collection, rows are like documents and columns are like fields. Got it? Now RDBMS stores structured data. It has structured data into it, right? It has structured data. It stores unstructured data. You can like put in dump, right? Let me also tell you one more thing, right? Adding a column inside this RDBMS becomes a pain. Adding one more field over here, very easy. You can have, see, suppose if I don't want to store my phone number over here, in MySQL, this space will still be taken. This space will still be created. This table will be created. There will be an empty cell over here. This will still be there. This place will still be there, even if I don't store a phone number. Over here, you can skip few fields also. If there is a field which is non-mandatory, suppose the city is non-mandatory, so I can just skip it. This document will not only have one field. This field can not be present also. There are some fields which are like required, if we make it required, but then some field you can just quickly skip. So this data is not structured in a particular format. It can change its type of values also. We will see all of it when we go and build the projects, but don't worry about it. I'm just giving you a quick overview of things, right, in a broader perspective. Now in RDBMS, we have a fixed schema. What do you mean by a schema? Schema means what this table will contain. This table will contain an ID, first name, last name, cell, city. It is fixed. It's fixed, right? You cannot change it very often. Changing the schema is a very big headache inside RDBMS, and we need to carefully think about it. People do it, application changes schemas, but changing the schema is not very flexible over here. But over here in NoSQL, it has flexible schema. You can just play with the schema. You can keep adding new fields. There are ways to deprecate the previous fields also and all that stuff, right? We keep doing that, but it's flexible, right? It's easier, I would say, in NoSQL, right? And trust me when I say this, because I have worked heavily on MySQL and RDBMS a lot heavily. And then I have also worked in NoSQL and MongoDB heavily, right? So I can say when I'm saying, I'm not saying it just like for the sake of saying it, right? It is very flexible. Now RDBMS always uses a structured query language. Structured query language. Take down notes. Hope you are taking notes along with me. Write it down. Don't take a screenshot or something. Try to write it down yourself. When you write it, when you see, I could have just taken a screenshot or I could have not prepared these notes, right? But I love to prepare notes because see, today I have notebooks with me, right? I have one notebook, I have second notebook, I have third notebook over here, right? Over here. Why? I still use notebook and a pen to take notes. Why? Today we have all sort of notions, digital form of taking notes and all that stuff. I don't like that. Why? Because when you write it down, right, with your hand, with paper, on a paper pen or a pencil or something, right, it gets into your head a lot, right? Some people call this as rote learning or something, that why do we take notes in the classes, in the college and all that stuff. But it's important. If somebody is teaching you on a whiteboard, try to take notes. It gets into your head even more at a deeper level. That's a process and that should be followed. It's not just you are hearing me watching this video and then just listening to me and you will absorb everything. No. Right? This osmosis will happen if you will try to take down notes, take some effort, because see, when you write something, your brain has to process what you are listening, then you have to articulate it in your head, and then it should come through words from your hands and you write it actually, right? So that cycle, that process is very important in learning, right? So do that. When you will write structured query language, if you will write it, right, then you will remember it. That is why I remember things, right? I write it, I remember it. So, and you make notes also. You can refer it to anytime you want to. And learning from somebody else's notes is a pain, right? If you will learn from somebody else's notes, it's a pain. If you have written it yourself, it becomes very easy to refer to the notes again if you go back. Okay, cool. So it has a structured query language. Now in NoSQL, the query languages also changes according to the types of NoSQL database. So in Mongo, we have something known as MQL, Mongo Query Language. In Neo4j, we have Cypher, right? This Neo4j is what? Did you see what type of database it is? Did you see that? Have you seen that? Remember, there is a Neo4j which I told you, graph database. It's type of a NoSQL database, right? And it has a query language which is known as Cypher. Okay, so it's known as Cypher. Now, RDBMS is tough to horizontal scale, right? If you want to scale your database horizontally, it scales vertically properly, But if you have to scale horizontally, there are ways to do it, but it's a little tough. It's tough, right, to scale it horizontally. MongoDB, NoSQL is tough to scale horizontally, vertically. It's structured in that way. It's designed in that way. That is why RDBMS, when it was designed, it was not designed to scale horizontally or something, right? There are ways you do that, but it's not actually, it's not a design principle of RDBMS in itself, right? But we do it. It scales horizontally also, but it's a little tough. Now in RDBMS, there are relationships using foreign keys and joins and all of stuff, right? Using keys and joins and all of stuff. Over here, you don't have keys and joins and all. You can keep nested data over here, right? In NoSQL, you saw, okay, you created hobbies and you created an array, you pushed it up, right? That's not what you do in MySQL, okay? So you don't do that. So now, RDBMS is good for read-heavy applications. And suppose if you have transaction workloads, if you have to put in some transactions, that is what you can do using RDBMS. NoSQL is very good for real-time data, big data, distributed. This distributed computing is a very, 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 very important use case of NoSQL database. Okay. Distributed computing is tough, very tough using MySQL, so they don't use it. General distributed computing, you use a NoSQL database. Okay. Now, RDBMS is generally used in banking apps where you don't have to worry, like banking apps has transactions, right? It's best suited for banking apps, RDBMS. And suppose if you want to build some analytics dashboard, if you want to build some real-time dashboards and all that stuff, if you want to store data in social media or something, right? Comments, post and all. So it's good to have a NoSQL type of database in it. Now don't understand that, okay, if I wrote social media over here, then Facebook is just using NoSQL and MongoDB. No, right? It would be foolish to say that. Companies use companies work in a very different parallel zone, right? When I was in Uber, right? Let me tell you, right? When I was in Uber, we used all sorts of databases. We have there is a famous database inside Uber that is known as schemaless, right? It's developed just specifically for Uber's use case, right? Let me just show you that also. If you are interested, right? If you are interested, then read about Uber's schemaless database, right? It's very fun, right? If you go over here, Uber schemaless, right? There would be a Uber's engineering blog. Yes. Read this article. Designing schemaless Uber engineering scalable data store using MySQL, right? So they basically in-house created schemaless and it is used for a specific purpose. There is a purpose of schemaless database. Okay. Now I can't, like, this video is already going a lot long, right? I'm not going to basically explain you the details of it, but read this article. You would find that why this was created, how it is better, right? What is the data model over here, right? Why do actually Uber had a need to create it, right? You can also read about the architecture and all, right? That Uber has very great engineering blogs. If you get time, go read about this schemaless, right? And it will be fun, right? If you want to be curious and want to read about it, right? When I was working for Uber, so we used to have brown bag sessions where people used to come and talk about schemaless database and all, right? So it was very fun to work with schemaless and all. So, and when the companies become big and they have a very unique problem to solve, they come up with solutions. They can't just directly use that versions which are available in the market. They can't just directly use MySQL. They can't just directly use MongoDB. They can up to a certain level, but if you are doing something very unique, you'll have to design your own type of tech. You have to build your own tech, right? Suppose if you think about how Google Maps stores data, it would be very different than how Facebook stores data, how LinkedIn stores data, how different social media apps would be storing data. If I say that it is used for why I am telling you all this is that don't get confused. If I say that, okay, it is good for social media, then what? Why? Where? Social media is huge. So I'm just taking an example over here, right? Okay, so right? So don't take it very seriously. Sometimes people take it very to the core, right? That okay, social media, we'll use MongoDB always, right? But first of all, think whether there is a use case for MongoDB or not, right? Cool. So this is architecture level thing. If you want to ask me that okay, which database should I choose, right? Should we use RDBMS? Should we use NoSQL? These are like higher level concepts which are much more into system design kind of a thing, right? When you design a system, then according to the product, according to the use case, according to the type of user base, you choose a database, right? For now, if you ask me, with the scale which we have on namastedev.com, we are using MongoDB, pure MongoDB, plain MongoDB, right? And it's working well for us. Maybe sometime later we might have to use something else. Who knows? Right? It all depends on the scale. It all depends on the type of product, what are the use cases and everything. Right? So the video is going long. It went a little longer than what I expected to be. But should I continue or should I not? I wanted to actually, I am in a dilemma. I wanted to actually create a database and show it to you. How do you create a MongoDB? How do you create a database? How do you put data into it? How do you get data from it and all that stuff? Cool stuff. But I think I should end this video right now. In the next video, in the next episode, I will actually go and tell you, and we will create a database. I will tell you the ways how you can create the databases and how you can write code to interact. We'll create our first database. We'll put some data into the database. We will create some documents. Let's not call it as data now. Now I can use technical terms. We will create a collection. We will put documents inside it. We will add fields to it, right? And then we will create a MongoDB database, right? That will be the first interaction with our database. So that will be just a very basic kind of a session, a coding session where I will write code. This was more of a theory type of a session. Let me end this session over here and see you in the next episode. But wait, before you go, I have one request. If you are liking this series, if you are liking Node.js, please share a word about it on social media. That will mean a lot to us. It takes a lot of time to prepare all this, give you all the knowledge that we have. Please share it up with other friends, family, and all your social media network. That would mean a lot to us. You can maybe take down notes and post it on social media, or maybe share some knowledge which you have gained from this episode on social media. That would be a great help to others who will read it and to you yourself as well, right? So learn in public and share what you are learning every day on public on social media. Tag me along, tag Namaste Dev official website and the social media pages, or tag me, tag Akshay Saini. I would love to know. Whenever I get a notification that somebody has tagged me, I go read their post, and I just love to see people learning a lot, right? These are recorded videos. I don't get to interact with you a lot, but then social media is a way where I can just go and see, okay, my students are learning, and I can see and I feel happy about it when you people tag me in your posts. So that's all in this video. See you in the next video with some code, with writing and creating our first MongoDB database and inserting documents to it. Okay, so hope you are excited. Hope you are excited about that session, and see you in the next one. Till then, bye-bye.